Yeah, okay. So today I think we will be building, we're going to start on the ETL pipeline. So we're going to start on the ETL uh, ETL pipeline. For the ETL process, that's the extraction, transformation, and loading. That's what we'll be covering for today's process. So, uh, of course, we'll be creating an ETL pipeline, and for that ETL pipeline, as I had stated yesterday, was that for the ETL pipeline, we are going to be extracting data from an S3 storage. I think yesterday I said something to do with a Blackblaze, Blackblaze, or was it Black? Is it Black? Yes. Yeah, I think yesterday we talked about the Blackblaze. So this is our S3 storage, and essentially what we are doing is that Blackblaze is our data lake or a data storage. So S3 object storage. So we are storing all our data or the raw files in a Blackblaze. Okay. Then our ETL process will begin by extracting that data from a Blackblaze. So if I can have, let me think sketch. So essentially, um, I just need a web version for this. The sketch, if I'm not wrong. Essentially, what I'm trying to do is that we'll have our object storage that will be from Blackblaze. That will be our object storage. Then in our object storage, that's where we will be storing all that data. Then we'll create an ETL pipeline. So that ETL pipeline will be taking that data from whatever storage we are having, then doing the transformation. So transformation, that means uh, uh, generally in ML, we'll consider, generally I will say we'll be working with, let me use, no, use vector field. Yeah. So essentially what I'm trying to say is that uh, we have our object storage. This is our object storage, and this storage contains all our necessary files. Okay, so this one is the Blackblaze open storage, and this one contains all our our data sets or files. Everything will be housed under this, so contains our files. So essentially, with the ETL platform, what we are doing, we'll be reading this data from here. Then we come up with the ETL process. So the ETL process, this is the extraction. So we're extracting from Blackblaze. Transformation. So extraction, then transformation. Transformation, that means we'll be creating those features. Then we'll be loading that data somewhere. So this is the ETL pipeline. So let's say this is our pipeline. Then from our pipeline, we will have the BigQuery. So this is I think I say BigQuery. So this is the BigQuery that will be our offline storage, and then you can create also Redis. Okay, so you can have BigQuery and you can have Redis, and all these two will be communicating using. So Feast will be like a tool sitting on top of this database. and Feast will enable us to actually talk within these two databases to extract that data if you want to build a model for offline, or if you want to also build a model for online predictions. Okay, that is what we are going to be building. So I'm not saying things that are in theory, but that is what we are going to be building under this process. Okay, so just know that this is the Backblaze. So this is our S3. Then we do our ETL pipeline. From the ETL pipeline, we extract data to BigQuery. That will be our offline storage. Redis, that will be our online storage. And Feast will be sitting on top of these two databases to enable us to do offline prediction as well as online predictions. So that is our goal and that is our intention. So today, I would like to focus more on the ETL process, the extraction, transformation, and loading process. Okay. So going back to the code itself, I think yesterday I shared with you the data splitters. So this is the different data that we will be having in our data itself. So we're having these tables. So make sure that you also create these tables so that mhm. Okay. So make sure you have all these tables set so that you're able to also follow what I will be doing. Okay. So once you have your table set, so we can start on the ETL process. So let me just clean my workspace, delete all these files. These are not needed for now. Okay. Then inside the I think I did create. So inside the ETL, so I'll create a new folder and call it the ETL. So under the ETL folder, I will try to include some of those files under ETL. Under ETL, I'll create the components. We'll create the components. The components will be a folder. Also under ETL, I'll create a new folder, and this folder will be, let's say, constants. Constants will be the file paths. Under constants, you need to create the underscore init underscore. I don't know. Is there any? Let me see if I can find it. Is there any extension that creates folder and the init.py in VS Code? I don't know if it should be. I don't know if there's any base extension for creating folder and is create blank Python module by. Okay, let me see if there's this. Let me say Python init, py auto init. We should be having that, creating these things one by one. Again, there's not py init. Py auto init. So auto Anyway, so maybe that one has not been. Let me find if that one has not been. Okay, finally, something that has not been invented yet. So I usually prefer working with this one, maybe. Mm, I usually prefer working with PyCharm because uh, once you select creating a folder, you don't need to worry about creating the init file. Just it will do that automatic. Okay, so that is the constant. Okay, so that's the components. So I'll create another component. I'll also create another, let's say, also create another, let's say, a entity. Okay. So that one is now okay. So entity, I don't need the components. Then I think the last one will be the pipelines. So we'll create another folder for pipelines. And also this one will need underscore. Okay. Now we have all these components, ETL and all that. So I will start. I will start with the config under conf. Okay, I also create another config. Let's see. This will be no. It has to be under the root folder. Okay, under the root folder, I'll create another one called config. This one doesn't need to be. This doesn't need to be. It does not need to be Python package folder. Okay, so don't need to create the init file here. So then config. So here we are going to create. I'll also create another folder inside. And this one I'll call this the ETL, and under the ETL I'll call it. Let me call it the first dimension products dot the YAML file. Okay, so config ETL. I don't need that one right now. Then we'll create another one. Dimension source.yaml. Yeah, then .yaml. Then just copy the rest. Just okay. So that one is it. So telemetry. Also another one, I'll call it inventory. Then this, then I'll just paste it here. So that's the spine. That is the entity table. Okay. So let's start with the first one, dimension products. So from the table products, this is how I'm creating that. So from the dimensions products. So for the dimensions, products. So what I'm doing, so this is the YAML file, and with the YAML file, uh, this is what I'm doing. So I'm creating the base folder will be the artifacts. So that will be the base folder. So all data, all objects that we'll be creating during the ETL pipeline will be housed within the folder artifacts. So within the artifacts folder, that's where each stage or each process within the ETL pipeline will be housed. Okay, so that's the artifacts folder. Then I will create a data root there and call it something like ETL if I'm not wrong. So we'll call it, yeah. So artifacts folder will have the ETL. Then the ingestion sources. So this is where we are getting our data source. So at first, I'm doing this like a double header. So that means that locally, I can still get that data from. I can still get that data from my local storage. But if I deploy this model into production, I can still get that data from the given source. So locally, this is the path. In a production setting, that means I won't be working within my workstation or this desktop. So that means that data has to be sourced from somewhere else. And that's why I'm passing also this, so that, I'm passing this so that irrespective of your location or your workstation, you're able to pull that data. Okay. So you're able to point that to Backblaze. So that's our S3 storage. So this is just the endpoint. You can replace it with yours. Then for the BigQuery, this is the table that I'm using. This is the retail omnichannel features. So this is the table that I'm using under that. Then this is the SQL query if I want to get to read from that table. Then this is the local target path. So that means that even locally, I'm able to import my features. Then this will be the target path where the resulting data frame will be saved. Okay. So irrespective of where you're working with, or if you want, you can remove the local target path or the local source path. But for this project, I wanted to include both so that I'm making it a little bit flexible for you, irrespective of your workstation. If I deploy this to my server, I won't have this path in place, but I'm able to source my data from the given S3 storage. So these will be the starting required starting columns, or the required columns: product ID, product name, category, supplier ID, supplier score, shelf life, spoilage, base price, cost price. Okay. Then the primary key, because we'll be using Feast for this. Yes. And so the primary key is very important for search, and so that's why we are also including the. I'm also including the primary. I'm also including the primary key for that. I'm also including the primary key. I'm also including the primary key. Then with the first event timestamp has to be in place. Then we have the date anchor. In case you're missing date, first will resolve using this. Then ETL root relative directory. So ETL dimension products. Then this is the baseline stats. So this is the baseline stats that we'll be getting from our data. And these baseline stats will be used when we are doing the inference. Okay, so when you're doing the inference, so right now we are doing the training. At some point, we'll have to do the inference. And for example, for a given use case, picture this: that let's say you're working on a particular model, and then the median value, let's say for income, is $10,000. Okay, then that's the median income, and someone who is above the median income, we can classify them as a high value client using an example. Okay, so that's a high value client. Then you find, let's say the median is 10,000, then you are classifying clients into low, medium, and high income brackets. Okay, but the median is 10,000, which ranks you in the median. Then within the inference, you get only 3 data points. Okay, but you are forgetting that you have that median $10,000, and so with those 3 or 5 or 10 data points that you'll be having, let's say the calculated median is 5,000. Okay, that is half of what the training median was, and so that at least we are comparing apples to apples when it comes to doing the environment. When we're doing a training, that we'll have to change the entire code. Okay, that's the advantage of using the YAML file. Okay, so that's the dimension products. I will go to the entity, and within the entity, I'll also create entity. Let me look at my entity. I'll create the config entity. I don't want to write this code again, so I'll just copy. Config entity has to be inside entity. This is the config entity. So the config entity, now we have specified the dimension products. So type safe schema for the dimension products. So we're converting that the YAML file into an object. So this is the object that will be housing all these configuration details. Okay, so we are converting from YAML file into an Python, creating an object on that. So again, artifact root, data root, root relative directory, the baseline starts, rows, source, local path, and everything. Okay, so we are listing that under this data class, and also we are using the frozen true so that we're able to lock this so that we cannot downstream cannot inject any variable within this class that might lead to errors. Okay, so to prevent that from happening, then we can just use the frozen true parameter. Okay, then once this is done, then we can now create our component. So the component dimension product component. Copy. So this is the component. This is the component. So for the component itself, as you can see, I'm using Polars. So Polars is my go-to guy when it comes to building these pipelines, because I'm assuming, or I'm taking into consideration that as we start processing more data, you're going to be having a challenge if you're working with pandas. Pandas, even though it's mostly used, but it has its own limitations, especially if you're working with massive data sets. And to avoid that problem, then you can use Polars for that. And in this case, I am using Polars. Okay, so then import the JSON, date time, config entity. So this is the object we are importing from config entity. And this is the logger step, the exception step, and this is the Blaze client that we are importing from that. Okay, so then I'm creating a class dimension products ETL. Okay, then I'm doing the initialization. Then I'm setting the inference. That means in the pipeline, we'll have if it's inference or if it's a local and so on. So that's what I'm passing it here. So the component allows for both. So if it's inference, we have to load that JSON file, so because that JSON file has the stats. Okay, but if it's for training, that's the default. We don't need all that. Okay, then I set the reference cutoff using the anchor date. I think we created the default anchor date here. Then retrieve the population baseline. So we have to calculate the baselines for that given population dimension product. So what's the population for that? The mean, medians, and all that information has to be calculated so that we store that information in the JSON file. Then we can load the stats, especially if it's from even calculating or creating new features. If you are creating features based on the median, okay, so that's where we have to calculate those, then you load those files. Then validate the raw schema, just check if we are missing values and all that. This is just like a validation step that we have it in place so that we make sure that our schema, what we have listed as our raw initial columns, are also present under this. Okay. Then we can fill this, fill the rationale, markup ratio. So you can just read this, then you can see how I'm filling such a table. So, other features, they're just like a logical step. So filling missing values, imputation, and all that. So this is what I'm doing under this step. Then we can do the engineering of the risk features. Okay. So I'm engineering some other columns. Okay. Daily storage risk. So 0 shelf life days means no shelf life was recorded. So we are filling that with 0.0. No time-based risk to be derived. Financial burn rate. So these are some of the instructions that I was following when I was creating these features. So some of these features like this, daily spoilage risk sensitivity per shelf days. So I'm taking the spoilage sensitivity, dividing that by the shelf life days. Then I'll be getting the daily spoilage risk index. So daily. If you want to get more information about the features and how I was creating them, I think I will share with you that specific file. Let me look for it. I think I created a documentation that shows how I was coming up with those features. I can show you that. So, find that document.
Shut up. We're going to go over there and eat in a minute. Relax. Are you guys starting to see the insanity of this guy over here? This is what she uses her shit for versus what guys use social.
The document itself so that you're also able to follow through. No. Yeah, I think I found it. So this is the document itself. So you can see from the products table. So these are assumptions that I was making. Supplier score is on a scale 0 to 10 or 100. So you can see the different features and how I was coming up with those features. Potential unit profits, a financial feature, formula that's the base price minus the cost price, presents the maximum profit possible per given unit. High margin items can tolerate aggressive markdown strategies, especially if you're working with creating the discounts. Okay, So markup ratio, daily spoilage risk, supplier risk factor. So 10 minus the supplier score. Inverse the supplier score so that higher values represent higher risk and so on. Then a supplier induced spoilage risk. I think this one was the one that I was talking about. Then the daily financial exposure risk category and so on, cost ratio, margin compression index, shelf life or time-based features, so spoilage velocity, financial burn rate, so formula, that's the formula, and so on. So all those features are baked within the ETL. So okay, then engineer the category deviation. So these are some of the features, 16, 17. So you can see I have about 19 features based on this. Then now we can calculate the benchmarks, median unit profit, median daily risk, average supplier risk, and so on. Then we can log these steps. So this one, once we have created that, then we can run the ETL. So run the ETL function. It now compiles all the methods and everything that we have done under that. So this is the function that the pipeline will be calling. And so the pipeline, where is the pipeline? Let me show you the pipeline. So for the pipeline, I think I have stage one. I'll just copy this into the pipelines, then I'll paste it here. So this is the pipeline. So ETL pipeline, stage one, dimension products. So again, I'm using polars. Then load.env, because there are some, the GCP client will be loading that data from that. So that's why I'm using the load.env. Then class dimension products ETL pipeline. Then this is the run. So this one looks into, is it inference? So inference, if it's inference or else training. So within your terminal, you can add is inference. Otherwise, if you don't pass that, that means that by default, that's a training step. So it will only do the training. So this is the environments where you can get the environment variables, a BigQuery, and so on. So I think I will set up BigQuery tomorrow, because I don't think I will do that today. So today was just to show you the pipelines. Then you can now the if this is the entry point, then I'm using the agpass so that you're actually able to pass whatever you. Let me show you. Yeah. So if you're running this, if you're running this like this PowerShell, so you can execute the pipeline in different ways. So I think you can, let's say, if you want to run this pipeline, so Python ETL, then pipelines, then stage one, then I can do inference. So inference. So for the inference, that means you will be running the inference, meaning that you're not training, but you're running the inference. That means the prediction. Then another thing that you can also do with the pipeline is that you can also try, if you run this like this, it means you're also executing this pipeline in the local setup. But if I add, I think prod, I have prod, I think inference local. I have, let me see. Supposed to be something like prod. Yeah, this one, prod. If you run prod, meaning that this is a production. So you want store data within your local. And then path, this one you're providing a path to the raw file itself. Then this one is for the local, run completely offline. Then this one is if you want to run in the inference. Okay, so I think my environment is not well set up. That's then I will be having problems with that. So I don't want to run this, but definitely you have a feel of the entire pipeline and how you can create it, okay, and how you can also execute the pipeline. So today I will try my best to also look into the other pipelines. Then I will share this. I will also share this so that at least you have a feature plus how it was generated, so it becomes easier for you to follow through. Okay, so I think that marks the end of my session today. So today we were talking about the pipeline, and I was a little bit intense when it comes to the first pipeline. Yeah, then the other pipelines will just be building from this. So I will try my best to work on the other pipelines tomorrow so that on Saturday we can run the Dagster, and the Dagster will enable us to run the entire pipeline together. Okay, so we'll have a central location or a repository where central location where we can execute the entire pipeline, whether it's inference or whether it's doing the training. Okay, I think that's what I will strive for us to cover tomorrow. So tomorrow we just work on on finishing up the pipelines. Then on Saturday we deal on Dagster, the ETL pipeline. I think that one can be done. So I don't think it's something that will be complicated. Okay, so that's what we'll cover that during that time. So yeah. So thank you again for your time, for taking time to join the session. And as I said, this machine learning data science platform where you can share ideas on how to build these systems. Okay, so as you also try to see what I'm doing, you can also try to comment, share your thoughts, share your ideas, how you've tried to solve such problems, especially if you're working on such production grade systems, and how you've tried to build those, and what tools, open source or proprietary tools, that you have tried to actually integrate to enable this process to be seamless. So with me, I'll just be sharing what I've done. Then maybe if you have anything, you can just go to the comment section, say how you think it can be done in a better, simple or efficient way. Okay, so that's it. Thank you for this for your time, and again, subscribe if you haven't. Hit that notification bell so that whenever we have such sessions, you're able to be notified, and you can join us when you're building these systems. So thank you, and until next time, see you.